This is Exponential Growth and Decay 6.1, video number 2. And in this video, we are going to start talking about how to solve actual real-world problems. So, we're going to start off with a little core concept here of talking about exponential models. Okay? So, some real-life quantities increase and decrease by a fixed percent each year. Or some other time period. The amount y of such quantity after t years can be modeled by one of these equations. You either have growth or you have decay. Okay? The a value is your initial value, what it's starting at. Okay? R is the rate, it's increasing or decreasing, and this is a decimal. So it's you take the percentage and you have to convert it to a decimal. Okay? So it's less than 1. Unless it's a really big increase that's increasing over 100%. And then t, that power there, is time. And then y is the amount you'll have after that amount of time. So the equations are the same, except for increase it's a plus, decrease it's a minus. Okay? So we will use those. But we're going to start off by solving this problem. So, the value of a car Y in thousands of dollars can be approximated by the model y equals 25 times 0.85 t, where t is the number of years since the car was new. Tell whether this represents growth or decay. So, if you remember the equation, it was y equals a, and this being less than 1 is just telling me it's decay. So, I know it's going to be, because it's either a 1 plus or a 1 minus, and that is less than 1. Okay, so I know this is going to be decay. And that makes sense. When you buy a car, they do not increase in value. They decrease immediately. So, identify the percent increase or decrease in the value. So that's dealing with this inside number, which is 0.85. So 1 minus r is going to equal that 0.85. Alright, and I'm going to solve for r. So if I subtract 1, I'm going to get a negative r equals a negative 0.15. Divide everything by negative 1, and I get r as 0.15. And if we want it as a percentage, you move the decimal 2 places to the right, and that would be 15%. So every year the car decreases by 15%. The value decreases by 15%. Then it says, estimate when the car value will be 8,000. So I want that to be my ending value. So I'm going to put that in for y. So I have 8,000 equals 25 times 0.85 to the t power. All right. Well, and actually I typed in wrote 8,000. But y is in thousands of dollars, which meant this car actually cost $25,000. So I actually need to get rid of those zeros. It's just 8. Okay? I needed to have read that a little clearer before I wrote it down. Now, we haven't learned how to get t out of a power yet. So what I'm going to do is start off by graphing this equation. I'm not going to graph the 8 yet. I'm going to graph 25 times 0.85, and you got to use the x. You can't put in a t, so the x power. And if I go to the table, I want when y is 8. And if you look right there, if you can see it, that's 8.01. That's about as close as it can get, which would be 7 years. So, t would have to be 7 years. And you can double check that by going to your graph. Now it's going to be off my graph a little bit, but it's over there. But I can push the trace button, and I think when x is 7, y will be 8. So I'm going to just type in 7, and it gives me that 8.01. So using the table is the best way, because we know the y value is 8. So find when the y value is 8, and the x value gives you your exponent. All right, next problem. we want to write an exponential model here. So in 2000, the world population was about 6.09 billion. During the next 13 years, the world population increased by about 1.18% each year. So we want to write an exponential growth model given the population y in billions and t years after 2000 and estimate the population in 2005. Okay. So we are going to write the equation. So we know it's growing. Okay, it increased, so I know I'm going to use growth. So that is y equals a times 1 plus r, I said 1 and I wrote something else, to the t power. That's a 1. Sorry about that. Okay, well, let's see. I don't know why. My starting value was in 2000, so I know a is going to be 6.09, and that is in billions. Okay, but y will be in billions as well. Okay, and then it gives me my rate, which I have to write as a decimal, so we have to move that decimal 2 places to the left, so it's 0.0118. Okay, so I'm going to get my equation here, and it will be y equals 6.09, and then it's 1 plus 0.0118 to the t power. I'm going to go ahead and do this to get my equation. So y equals 6.09, and it's 1.0118 to the t power. So there's my equation that I'm going to use. And this wants me to find out what the population is in 2005. Now remember, we started in 2000, so our time here increased by 5 years. So I want to know what y is when t is 5. So again, I'm going to go to the calculator and I'm going to type in this equation. Whoops. So 6.09 times 1.0118 to the x power. And if I go to my table, I want when y is 5. Oh, I'm sorry, x is 5. Oh my goodness. Helps if I read the problem right. X is actually 5. So I'm going to go where x is 5. And I get 6.4579. So I'm going to say y is about 6.46. And this is in billions, so we'll say billion. Okay. Now, we could have just plugged that into the main screen. Sorry, I'm pushing all kinds of buttons. The main screen and just type that in. I was still working like I was on the last problem here, and put it to the power of 5, and we would have gotten the same thing. Okay? So you have multiple ways to get to your answers. And now we want to estimate the year when the world population was 7 billion. Okay? So we're using the same equation, but this time y is going to be 7. So that's when we use the table here. I got a little ahead of myself. And I need to find where it's 7. Well, at 12 years, that's looking like as close to 7 as I'm going to get. Okay? So this is when t equals 12 would be part of my answer, but that's the number I'm looking for in the equation. But this is wanting the year. And remember, we started in 2000. So I need to take the year 2000 and add 12 to it. So my answer is 2012. That would be the year. All right. So now, go to your practice and do problems numbers 21 through 23.